Hello grade 12, Mr. Gomez here, and we're going to be looking at another video on work energy and power. Alright, so the topic for today in the video is work energy theorem. Now, before we go to work energy theorem, let's record what we learned about work in the previous videos. First of all, definition of work. Work is the product. Work done by a force is equal to the product of the force multiplied by the displacement multiplied by the cosine of the angle between the force and the displacement. Then we also learn that obvious on the object there are many forces acting, and then you can get the net work or the work done by the net force, and that is equal to the algebraic addition of the work done by all the forces. Okay, so this was done in previous videos. This is recalling, this is S3. So definition of work is the product of force multiplied by the displacement and multiplied by the cosine of the angle between the force and the displacement. The net work done by the net force is equal to the algebraic addition of the work done by all the forces. Now, let's record something that was done previously in previous grade, which is kinetic energy. Now, kinetic energy is the energy of motion. Every object that moves have kinetic energy, and kinetic energy is equal to half mass of the object multiplied by the speed with which the object is moving to the power 2. Now, the work energy theorem is relating these two physical quantities, the net work and the kinetic energy. And the work energy theorem states that the net work or the work done by the net force, the work done by the net force, the net work is equal to the change in kinetic energy. And this one in a formula could be expressed like net work is equal to change in kinetic energy. This here is what we call the work energy theorem. Net work is equal to change in kinetic energy. Remember, any change in physics is final minus initial. So change in kinetic energy will be final kinetic energy minus initial kinetic energy. Now, if you substitute this one into that equation, we have that the net work or the work done by the net force is equal to final kinetic energy minus initial kinetic energy. And you can go on, you can substitute the formula of kinetic energy. You can substitute the formula of the kinetic energy, which is here, to each of the kinetic energy initials and final. And we'll have that the net work is equal to half the mass of the object multiplied by the final speed of the object square minus half mass of the object multiplied by the initial speed of the object square. This here, all this is what we call the work energy theorem, which we are going to use throughout the year and at the end of the year examination. Okay, next time we're going to see how to apply this theorem. It is not a law, it is a theorem. How to apply this theorem to some example. Okay, thank you very much. Next time we'll see examples.